hello, ladies, gentlemen, boys, and girls. Good morning, good afternoon, good evening from wherever you're joining us. I can see many of you are active in the chat. I asked when we started, where are you joining us from? And I can see we have someone from the US, we have Kenyans in the house. We have guys from Zimbabwe, we have guys from Ghana. Nigeria is represented widely. And I can see someone from Morocco as well, guys. We're so excited to have you here today. Welcome to this week's webinar. My name is Simio. I am going to be one of your hosts today. And as you can see on your screen, we have the very beautiful and amazing data scientist who will be taking us through the session, Munesu, on the call as well. So really excited to have you here, guys. And before we get started, I'd like just for you to take a moment and just appreciate the journey that you've been on. You guys are doing amazing, amazing, amazing work. We know it's not easy. It takes a lot of courage, a lot of grit, a lot of resilience. So just take a moment to pat yourself in the back and, cheer yourself up because you're doing an amazing job. We see you and we appreciate everything that you're doing. So before we get started, we'll just walk through the agenda really quickly. First of all, we are going to look at the rules of engagement, and then we'll go through the main session with the amazing Munesu, and then after that, we'll have our Q&A sessions, and then we'll close with updates and announcements. So the rules of engagement, as usual, if you have any questions, please let us use the Q&A section. And we will be opening the chat ad hoc in between the session. So be on the lookout for that as well. Let us be active. Let us learn and listen, learn and engage, because that's why we're here. I mean, every webinar, if you've been attending all our webinars consecutively, you'll understand that there's so much that is shared. So make sure that you're active, that you're listening, and that because this is one of the steps that you're going to take in your journey to become a data expert. So at this point, I am going to welcome the amazing Munesu, our data scientist and technical mentor, who is going to take us through the main session. So guys, let's give Munesu some love as she takes us through the session. Welcome, Munesu.
Thank you so much, Peter. And hi, everyone, once again. My name is Munesu, as Peter has introduced me, and I welcome everyone to today's session. So I think, first of all, before we actually dive right into the session, by show of emoji, I want you to think of this. Think 4 weeks, 5 weeks from now, you're going to be standing as a data analyst, like you'll be a full-blown data analyst, ready to get your certificate. So what emotion, using your emojis, do you think you'll be feeling in that moment when you realize, like, oh, wait, I'm actually a data analyst now? By show of emojis. All right. Like after all the hard work, oh, I can see, okay. I can see there's some party people. Please don't mind me. I'm reading from another screen, the charts. So yeah, if you see me looking elsewhere, it's because I'm reading the charts, guys. Okay. Oh, okay. Some lopsided, some love, some cool emojis. Okay, that's great. That's great, guys. So yeah, I want you to hold on to that feeling, right? Because it's a very, very short time away and we are almost there. So I want you guys to hold on to that feeling. And then speaking of, so that our session stays as stable and as smooth as possible, I've been having connection issues. I'm going to turn off my camera so that there's just slightly less bandwidth to interfere with the webinar so that we've got a smooth webinar. So I'll be here and we'll be talking to each other that way. All right. So sorry. without further ado, let us now go into the webinar. So okay, let me go back actually. So before I actually start with subqueries and we start building, let's warm up our minds a little bit again and tell me in the chats once again, what are the big six? Let's see for those that do their research outside of just their Athena content or those that are reading, those that are going through the Athena, the Athena content. Let's see. What are known as the big six SQL queries in SQL? What are the big six if you know them? Another way to put the big six is the queries that are used most commonly within SQL or SQL. What are the big six? I see select, where, from. All right, yes. Insert, select where from, where, create, select from where, group by, having an order by. Yes. Okay, I see a lot of you are getting it. Select from where, group by, having an order by. There we go. All right. Thank you so much, guys. So the big six queries that are used in most queries in your SQL journey are your select clause, from, where, group by, having, and order by, because those are the most commonly used clauses that you'll use within your SQL journey all the time. So with that in mind, let us now go into subqueries. So today's teaching, it's going to be accumulation of everything we've been doing from flowcharts and pseudocodes to our Google Sheets and now into SQL. So everything that we've been learning, you're going to start seeing bits of it coming out throughout the webinar. All right. So without further ado, let's now go into what subqueries are. So a subquery, also known as a nested query, is a query that is embedded.
Hello, Minisu.
Yes.
You are breaking.
Uh-oh. Can you hear me now?
Yes, but you're cutting still.
Oh, okay. Let me try and change the network.
Oh, maybe it's just me. Oh, okay, no, it's my internet. Apologies, guys. Okay, it's me. It's me. Sorry. Please go on, Minisu.
Okay. All right, no problem. But to ensure it's more stable, let me just be joined on one device to make it easier. All right, just in case I do break. So your subquery, remember it's a nested query and it's within another SQL statement. So this query can be found in either your select, your where, from your join, your insert, your update, or delete clauses. So it can be found in any other clause. So why we've got this image here is because I want you to think of a subquery as like a little helper. So here in this image, you've got this bigger robot that is there, and then you've got a smaller robot that's there. So imagine of your normal query that we've been building for the past 3 weeks, for example, where let's say if we wanted to find the average scores, we would get like, select, let's say a student, and then, get the average of the scores of that student from the students table. And so our little subquery helps us to actually execute the bigger query. And now subqueries, they enable us to retrieve data from one or more tables based on the results of our little helper here, which is the inner query. And it offers us alternative options to joins, functions, and window functions. All right. And so here we've got just a little sample of what this looks like an ordinary query, right? Where we would say select average from a certain column, and we get it from our certain table. Now, this is a normal query that we're used to. Now, if we want, this can actually then turn into a subquery. where you then insert this normal query inside another query. So as we said, it can be found in your select clause, or in this case, it can be found in your where clause. And so this is why we call it the inner query. So what I want you to remember is that the subquery, just think of it like the little helper that helps your main query. All right. And now when you're using subqueries, when there are nested queries present, the inner query is executed first. So our little helper is always the one that is executed first, and then the main query or the outer query is then evaluated or executed. The subquery is best used when you need to perform a one-time operation or filter a subset of data without reusing it later. So let's actually go through an example to maybe help us sink in or understand the subquery logic better, right? So suppose we wanted to select the students who scored above the average of all other students. So when we're building that query, the normal query would start with, okay, so let's select and get the average score of all the students. And from there, this is our query, and now we want to build up on it. So this is an inner query within the larger query that executes first and calculates a single average value of all the students, and it is then used in the outer query as a filter because it's in the where clause. So now the bigger query now gets our information that we need to see in the results, like, okay, we actually now need the name of the student, the grade of the student, and their current score. And now, because the inner query already has the average score, we can then see like, oh, okay, so against, all the other students, this is, or against their own score, this is the score of that student. That's why we call it a little helper. All right. So if I know a lot of people love food and they love eating, so think of the main query as, the main chef, and then the side query or the sub query as, your sous chef, the one that's always, or the assistant chef that's always helping with everything there. All right. So now that we have a better understanding of a sub query and that it is there to help with the main query, and that it is used only one time in one-time operations, we can then go into more detail about the subqueries in the different clauses. So subqueries can be used in different parts of a SQL query, and this is depending on what you are trying to achieve. So where you place your subquery will affect how the results are used. All right, so we'll go through 5 clauses here. So the very first one is the select clause, where, you always reference, the column that you want to use and the results that you want to see, right? And so when you use a subquery in your select clause, you use it to calculate a value for each row in the result. And so what it essentially does in that select clause is it results in a smaller data set. And so, for example, if we're getting that average, it shrinks down rather than reading the entire table, in the main subquery. Now we're only looking at, let's say, that average that we wanted, which is why we're saying it results in a smaller data set when you use it in a select clause. Now, in your from clause, remember every time we say from, we input a table. Now, when you replace that table name with your subquery instead, you create a temporary table that main query can use. So anytime that you input a subquery under your from clause, it then becomes the main source of your main query. So, when you put your select, maybe select student from the data or the table that it will now be referencing is the result of your subquery. All right. Now, when you put it in the where clause, what it does is it uses it filters rows based on condition. So remember where filters the conditions, filters our data based on the condition that we give it, right? And so when you put your subquery within the where clause, what it also does is it filters those rows based on the condition that we are giving it. The result, though, is that it only gives us the matching results, right? And so if the condition is not met for the subquery, those results will not appear to us, only the matching results. So for example, let's give a very simple example. Let's say we're looking for students who are scoring above average and who are scoring, above average of the class average, for example. Only the students that have, let's say the average is kept at 50%. So all the students that, get results from 50% and above are the ones that then come when we put that subquery in the where condition. All right. And then you've got the subquery in your having clause. So the subquery in your having clause is used to footer groups of rows. This is after aggregation. So the filtering will be based on a condition of comparing the different data that we have. So remember, our where clause, it groups things. Then the having clause filters those groups that we've created in our where clause by the rows, right? Depending on the aggregation. And so think of it as we've got a very big box with many things that we want to put things in, which is your where. And then the having is now a subset of the bigger box where we want maybe, let's say, Legos, right? We've got multicolored Legos. There's pink, blue, white, but we specifically want just the white Legos. And so now it's filtering based on, okay, because we want only white Legos and we've aggregated it like all of them are like 100. That's where you use your having subquery. And then finally, you've got the join query, which I think this one is usually the most straightforward one, where all you're doing for your subquery is you're combining the data from multiple tables. So it's combining the data from 2 or more sources. All right. So now that was subqueries and the different uses in the different clauses and the result that you can expect from it. So now that we've understood subqueries, let us now then go into common table expressions, or otherwise known as CTEs. Sorry, excuse me. So a common table expression, or a CTE, is a named query that exists within the context of a larger query. So here, why we highlighted the part named query is because your subquery, you just do it, it doesn't have a name unless you alias it, right? But now, if you take that subquery and put it within a CTE, you can actually give it a name. And so now it's got context within a larger query. So CTEs temporarily store the results such that they can be referenced later by other queries, other CTEs, or even itself. So like on this image that we have here, you can search your CTE or subquery with the little one on top, and then the queries below it then start referencing this top query right there. And so let us look at the syntax of how the CTE is built. So a CTE consists of 3 main parts. The first is the big query, which is, 2 queries in one. The second part is the inner query here, where you start with your with clause and you give it a name and the column list that you want, and then you define it by putting your subquery over here. And then you can now reference this inner query with your outer query that uses the CTE. Right. And so a CTE is only accessible within the larger query. This is the one with the orange border here. in which it is defined and will be lost as soon as the execution of this query is completed. So what do we mean by that? It means that once you run this purple box over here, once you run this query, you cannot use your CTE any longer, right? And so what happens is you write your subquery here, and then this becomes like a table that you reference with your outer query. And once you run this, the CTE can no longer be used. All right. And so that is what a common table expression is. What it essentially does is it's making it easier for us to be able to read our queries and to make everything more legible, more clean, and more easier to read. All right. Now that we've seen, okay, so that's the structure of the CTE, and that is what is going on, let us actually go into an example so that we can at least solidify what we're trying to see of what the CTE is, all right? And so suppose we want to compare the total salary with the average salary in each department, all right? So in our query, as we said, the CTE starts with the with clause. All right, so remember we're trying to get total salary. So we can name our CTE as salary totals, right? And now we build the query where we're trying to get just the total salary. And so we say, okay, select the department, get the total of the salary, and we alias that as the total salary. And then we count the department, because remember, we want in each department the number of employees. So the count of each department, we'll name that as number of employees. We get all the information from the employees table, and then we group everything by department. Because at the end, what we're trying to get is the total salary for each department. Right. So this is what this query is doing. And it's like a subquery or the inner query of our CTE. And so now that we've built and we get the total of each department, we can then build on to the outer query and then say, now give us back the department, the number of employees that we created here, the total salary, and then we divide that total salary by the number of employees. Why do we do that? So we can get the average salary. And where do we get this from? We get it from our CTE salary totals. And so this is how the CTE works, right? You've got your inner query, and then you're using the outer query to get the results from your inner query. All right. So yes, as I was saying, inner query, and then the outer query references that. So in the example that I just walked you through, we create a CTE salary totals, which calculates the total salary and the number of employees in each department. We then use the main query to get from the results of our CTE the average salary for each department by simply dividing our total salary and number of employees. And so that is how the CTE works, right? It's just breaking the much more complex logic or question into small, more manageable parts. All right. Now that we've gone through subqueries, we've also gone through CTEs, you can see that the concepts, they're actually beginning to build up and they're leading into each other, right? We now go into views. So now views in SQL queries, SQL queries can return tables or result sets that can be assigned to a virtual table. This is what is referred to as a view. They are reusable virtual tables that simply frequent complex queries. They're used when there's a complex query that is often reused across multiple queries. So, picture here. I want us to picture, the circles, the dark black blue circle, the white circle, and the gray circle here is our database. And these are our tables that are there. And the view is this little icon or this little window that is allowing us to just peep through the data and saying, oh, okay. So it's like a little virtual table that allows us to peek into the other data that is behind it. All right. And so that is what a view is. And unlike the CTE, where once you run your outer query, you can't use it anymore, with the view, you can actually use it multiple times. All right. And so what the benefits of a view are that it's dynamic, which means it does not store data. So remember, when you create, your query, like select from and everything, and the result comes out, that is committed into the memory of SQL. But a view, because you call it a virtual table, it actually does not store any data at all when you do the query. It stores, the information is stored within the other tables that are there, which is why we call it virtual, or think of it as a ghost. It's like a ghost table that's just hovering, but it's not there, right? And then another advantage of the view is data abstraction. So this means it can hide complex data. So imagine you've got a lot of complex queries that you have built up, and maybe you need to present your findings or your query to an external stakeholder. You can't let them see, your many, like, sub-queries and the complex queries that are going on. The view allows you to hide all that complex data, all right? It also restricts access to data for different users. So what this means, let's say, for example, we've got medical records with a person's name, address, and their condition. Because of data privacy policies that are in place, you may not be allowed to show like, oh, this person's address and this person, let's say their social security or ID number and stuff like that. So the view actually allows you to hide all that sensitive information as well, and it won't show that sensitive information. So that's another advantage of a view. The third advantage is that it's read-only or updatable. That means you can't modify your data using the view. So remember how we said the view is like a ghost table that's not there. It's not committed to memory. And so because of that, it becomes a read only, and you can't modify your data. So the data that it is showing from the different tables underneath, you can't modify that data with your view. And so if you make a mistake, for example, when you're doing your query and you're like, oh no, how do I uncommit this mistake? The view helps you to make sure that it won't commit or change or modify the data. All right. So these are just some of the benefits of a view. So now, why use a view? For example, so most organizations, they handle sensitive data such as personal, client, and employee information. Different users can actually then be authorized to use or view different parts of the data and the system. All right. So for example, regulatory compliance, it ensures that only the relevant data are accessible to meet the industry compliance regulations, right? And so we need to make sure like, okay, as a company or as the data analyst who's working on this information, only we stay compliant with what is expected, and we hide any sensitive information. For cross-department reporting, now when you're working with other teams and you're in a bigger organization, right, you need to cater to each department's data requirements and tailor to their reports. And so, let's say I'm from, the tech department, and the finance department is asking, I can't show them information about the tech department. They only want to know information about finance department. And so a view is useful in that we can then say, okay, just show finance department information. And then you also have third-party integration, which are your external stakeholders, right? And for them, you don't want to show them all the information that you have. Instead, you just want to show them specifically what they asked for. And you can do this with the view hiding the information that is not necessary for them. But this slide, it's on Athena, so you can go through it. There's more in-depth explanation on this. But that was just, a touch-up on what views are and why we should use them. So now that we've gone through subqueries, CTEs, and views, you might be wondering, like, okay, so how do we define it again? What is the advantage of each of them? What's the disadvantage? And when is it best to use each case or each function, right? And so we'll go through this function by function, just to refresh our memory once again. So by definition, a subquery is simply a query nested inside another query. Helper query, assistant chief. CTE is a temporary named result set that can be referenced within a query. So named subquery, that's how we remember it. Now a view, by definition, is a stored reusable query that behaves like a table. All right, so we're committing that to memory. Now the scope of when to use each of these. For the subquery, you use it it's local to the specific query within which it is used. So you only use it within the same query and it can't be reused. For the CTE, you define the name within a single query execution. So once you execute the outer query, we can't use it again, right? And then for the view, it's persistent across multiple queries, which means you can even query it 6, 7 times after the fact that you've written your view. All right. Now the advantages of each of these for the subquery. It is useful for filtering and simplifying conditions within our queries. When you've got like a complex logic that you need to follow to build your query, you can use a subquery to simplify or break it down. A CTE simply improves our readability and can help us actually break down more complex queries. So fun fact here. Did you know that you can put up to 16 queries within one query? So you can put up to 16 subqueries within one query. Imagine if we are using subqueries and we're putting 16 of them, we're not naming them. At some point you're going to lose track of what is going on and completely forget, what is happening. And so a CTE allows us to then improve that readability and break down all that complexity into, oh, okay, so this is what's happening with each query. Our views, the advantage is that they improve query reusability and they encapsulate complex logic. And so unlike our CTE and our subqueries, we can actually use it a lot of times, all right? And it also covers all the complex logic. Now the disadvantages of them, the subquery, is that it can make queries harder to read and maintain when they are deeply nested. So as I said, when you're up to, let's say, I'm sure you won't even go up to 16 subqueries. By subquery 3, 4, you'll be like, okay, this is too hard. It's too difficult. I can't even remember why I started building this query in the first place. So that's the main disadvantage of subqueries. CTEs is that they're limited to the scope of the query execution and cannot be reused outside of the CTE, right? And the view, the disadvantage is that it has performance overhead if the view is not indexed. So what this means is that every time you now take out your view, remember it's just showing you a snippet of all the other tables that are behind it. The disadvantage is that it goes over all the tables and over all the rows in those tables every time you execute it, which means that's a lot of computing power that is going on. So the best way to not, have all that computing overhead power is to index it, to say, okay, go to this very specific column and this specific row to avoid that computing performance overhead. Now, when is it best to use any of these? So for a subquery, it is best used when a query requires a small part of a result from another query. So that's why we're saying the aggregation, like, okay, we want the total of something or we want the average of something. That is when you use your subquery. Your CTE is when you need to now break down a complex query into more manageable parts. So you see like, okay, the query I'm building using the subqueries, now it's becoming too complex. I'm losing track of what's going on. That's when you start inputting your CTE. Now for your views, you use it when you need to enclose and reuse that query logic again and again. All right. So, that has been the, the scope of how each of these works, right? And so now we will go into a demo of these things. So guys, because I saw on the community, someone was asking that they couldn't find the notebooks that I was working with. So it's always on the demo slide. If you're looking for the notebook and the MySQL file that I'll be working on during the demo, they'll always be on the demo page where this will be your database that you can put in and run so that it comes out. And then this will be the notebook and MySQL files that you need for it. And it will be in a zip file that you need to download, and then you can open them. All right. With that said, we will then move on to our notebook. So before we do the notebook, or before you open the notebook, guys, just make sure that your SQL Workbench is running and that your instance is on, and you log into your instance, and then you can then go to your notebook. Let me go back here, and then you can start running. That way, you need to make sure that your connection is established. Otherwise, you might have an issue, especially when you run this particular line once again. All right. And so we are in this notebook, and we are going to just do a couple of the queries here, and then we'll move over to MySQL Workbench. Once again, just in case you weren't here last week, I'll explain why we're using both Jupyter Notebook and MySQL Workbench. So for Jupyter Notebook, you've got an exam that is coming up next week. And so you need to get used to actually using the notebook setup and how it works. All right. And then, yes, so I can see a surprised face there. Yes, there's an exam coming up next week. But don't worry, guys, it's just accumulation of all the stuff that you have been doing over the past 4 weeks. And then why we also show in MySQL Workbench is because that is the industry standard, right? And so in most workplaces where you will go, you're going to use tools like MySQL Workbench, BigQuery, Postgre, and all that stuff, which is why it is very important for you to actually get used to working with tools like MySQL. All right, so now that I've stressed on that, we can then move on into, but here's the rainbow on the other side, guys, for all those that are doing the shocked face emoji, is that after next week, you'll be going into what most students feel like is the breather, the breather module, which is visualizing data, right? And so now you're going to pull all those different insights, everything that you've been learning, and you're going to be building very cool and very amazing dashboards, and you're going to probably enjoy it as well. All right. So hang in there, guys. Keep on pushing. We do the hard things here at ALX. All right. So much like last week, we are continuing with the same data set that we started off with last week. And so if you have this data set, all you'll be doing is you're continuing to build your queries from there, right? And so our tables, let's refresh our memories once again. We've got our customers table, we've got our orders table, order items, products, categories, and departments. And so what we simply do is you load in your SQL Server, put your password, guys. Where it says your password, please put your specific password that you have. For this one, there's a document that I believe was shared with you guys in case you've got special characters, because it does throw errors when you've got special characters. It's there on the community space. Just look for it. If you're still getting problems because of special characters in your password, yeah, look through how to actually then put in your password there. All right, so once you've loaded your information, you've connected to your SQL Server, we'll then take a look once again at what our data looks like. So here, I'll simply say, oh, okay, let's look at the customers. We'll limit obviously to 5 because we don't need to see the entire database. And we'll do the same for all of them. For those wondering how I'm running it, I'm simply pressing, is it Shift Enter to get these. So here we just quickly taking a quick glance at our data and what it is holding. So that just in case, maybe I misspell something or I put the wrong, the wrong name, we can always come back and glance through these things, right? And so now that we see like, oh, okay, these are the tables that we have and these are the columns that are there, we then go into our learning. So for this part, what I will do is, since everyone is going to be able to access the notebook, I'm just going to touch up on just a high touch on, the key highlights of each section, since we already went over most of the stuff within the slides. All right, so refresher once again, subqueries, nested queries, a query within another query. Think of it as a question inside of another question. So for example, if I was to ask you guys like, okay, so, for example, if you're to ask me a question like, okay, so how did you come up with this material for the webinar? I would then maybe ask you a question of, okay, before I answer that, what do you think how do you think I came up with the webinar? So that's a question within another question, right? So that's your subquery. What we can note of it is that the output can be individual values, like a single column, multiple rows, or even multiple columns that can then be used in our main query. It is important to note that it is always enclosed in parentheses, and that's your brackets, and can be used in the different clauses that we already highlighted within the slides. So again, the benefit, as we said, was to improve query efficiency by reducing the amount of data processed by the main query. And then from there, we're like, okay, we understand what subqueries are. We then went into CTEs. And remember how we said it's a named set of results that keeps our code organized, right? And so the output of that CTE or the inner query can be reused multiple times in our outer query. And remember, our syntax for that CTE is with. So anytime you actually just type with in your SQL database or in your SQL tool, like MySQL or Jupyter Notebook, it will automatically say, oh, they're trying to write a CTE. And so with that, you then give it a name for your whatever you want to name your CTE or your subquery, and then you say as, you open parenthesis, then you define what it is that you're trying to get, which is your inner query, and then the result set is what we then use over here in our outer query. All right. And so we also went through the clause usage. The benefits, you already know them by now, guys. So I won't be going over those. And so just a note to remember that subqueries are nested within another query and they're executed first, right? And so it is important to remember that they're executed first whenever you write your bigger query. And then their results are the ones that are then used for our main query. All right. All right, yeah. And then remember that you get from your select, your from, your where, your having, your join. So these are notes that you can all go through just to simply see how to go, how to achieve each of them. Or when you're trying to think of how to build your query, you can just simply go through these notes and say, oh, okay, so this is where I need to build my sub query, all right, or my CTE. Now, with that being said, as we said, how to choose your CTE or how to choose your subquery, it is when the logic is complex for your CTE and you need to reuse it in the same query over and over, then use a CTE. If there are many intermediate steps that you need to handle, use a CTE. If you have multiple joins and aggregations, use a CTE. Subquery, you use it when it's much simpler code and you don't need to reuse it. Use it when you have quick inline calculation, like just one aggregation, one and done with. And when you need to use the results in multiple places within the same query. All right. So now that we've gone over, okay, so this is how maybe I can choose which clause to put my subquery or CTE and how to, choose which one to use. Let me actually give you just a few tips and tricks on how to then build your subqueries and CTE. So the very first thing you need to do is to understand what your main query needs. So you need to think or picture of what is the result you actually want to see on the screen. So for example, if I just quickly scroll up, like you need to imagine what is it that I want to see when this pops up, right? So have that in mind when you're building your query. Number two is you need to write down the subquery or CTE as its own query and then run to see if the results are coming out. And I'll actually show that how to do that in a moment just now, all right? And so then, after you've seen like, oh, these are the results that the subquery is giving, then you can add on, your main query or the outer query that you want for your subquery or your CTE. The third tip or trick I would give you is make sure the output of your subquery actually aligns with what your main query needs. So for example, if you are looking for like a single column that you want to use in your main query, make sure that your subquery is just giving you a simple column, or it's giving you multiple rows, or it's giving you just one value, like a total, right? So make sure that it aligns with your bigger query. The fourth point is to remember to always look for common columns or keys in tables when building your queries, especially for joins. Remember foreign keys, primary keys, we went through it last week. So that's, always look for those commonalities, always look for those keys, primary keys, foreign keys within your tables. When you're building your queries, it makes everything so much better and easier, right? And the final one is use group by when you are using aggregation functions and you are selecting non-aggregated columns. So non-aggregated columns, it's your stuff like that don't have numbers, that you can't aggregate, like names and stuff like that. Always use group by, all right? So all non-aggregated columns in your select clause must be grouped in the group by clause. So for example, like customer ID, we can't group that. So you need to put it in your group by clause over here, right? When you're building a query. So now that I've taken you through the tips and tricks, we've gone over, okay, the theoretical part of it, I'm sure now everyone is now ready to actually dive into the actual meat of the webinar. So I will take you through how to build a subquery. We're going to be going through 7 questions and we're going to go very slowly from beginner level into more intermediate stuff. All 7 questions, they're built towards, what is coming in your integrated project as well. So I won't be giving you write out answers, guys. That's not what's happening here. What I'm doing is I'm just showing you how to build the logic of what's to come in your integrated project, all right? So if you get the logic, you can, even if when it's frustrating you, and you're like, okay, how do I do this? At least you would now be able to break it down into smaller steps of, okay, this is how we actually achieve it. All right, great. So now that we're there, let's start by building a subquery. So to start building the subquery, remember how I said, always start with the results that you want first, and then add the main query to it. So our first question here will be, let us find the orders placed by customers who live in Littleton. So if we go back here to our customers table, remember this is the information that is there. And now we want to find where it says customer city. We want to find the orders of those customers that are living in Littleton city. All right. And so the first thing we do here is we say select and then customer ID. And from there, we use from the table customers. And then where, now we're adding a condition because we want only those who live in Littleton. So our condition here is where the customer city is equal to, and we'll enclose this in quotes, little, is that the correct, Littleton. Okay, there we go. And we put, don't forget to put this, because I know some people have been frustrated by forgetting. So let me show you what happens when you don't put that. And I ran this query. Okay, I'll show it in my SQL Workbench. It usually does not give an output, but always remember to just put this thingy here. All right. And so here we can see like, oh, okay, this are the customer IDs or the number of customers that come out without the that live in Littleton, right? And you can see like, oh, it's actually 8 customers that are from Littleton. So now that we've got the result of, okay, these are the customers that live there, let's now build from this same query. So what I'm going to simply do to save us time is I'm going to copy this, and then we're going to come down here. Now we're going to build on this same query. So remember how our question had asked us to find the customers, the orders placed by customers who live in Littleton. So right now we're just finding customers who live in Littleton. We didn't even ask anything about the orders. So now we're going to focus on the orders part. All right. So now we're going to get the orders of those customers that we have. So we then say select. Now we're building the outer query or the main query. And I'm just going to say select all from our orders table, because that's where we want to find out where the orders were from. And then we're going to input customer ID. This is where primary key, foreign key, the matching columns within our 2 tables. And then we're going to say that in, and what I'm going to do, remember your subquery, you enclose it within your parenthesis. Here we go. I'm just going to shift that there so you can see that this is like your subquery over here. We enclose that in parentheses again to make sure that we're going. And then when we do that, now when I run this, you can see these are the orders that the people in specifically Littleton ordered, right? So you can see like, oh, this is the date that they ordered in, their customer ID, and the order status. And so, as you can see, we simply built okay, so this is what the result that the query, this main query was going to use. And then we got the orders. So we got the people living in Littleton, and then we simply got their orders. So that's what a subquery does, right? It breaks down, instead of having to join like, join customers and orders, and then on this specific condition, do this. The subquery simplified that for us, all right? And so now that you've seen the result and the output of your subquery, now let us go on to the next one. What I'm just going to do, I'm going to click on this just to hide that. If we need it, we'll pop it back open again. So now that we've built our subquery, let us now go into the CTE and see how can we turn this subquery into a CTE. So what we do is we come down here, and remember, when you're starting your CTE, you start with the with clause. So I'll just say with, I'll name my CTE customer city, and then give it as, I'll define it. Here in our definition, I'll simply paste that very first query that we had from here. Where is it? Remember, this is the query I'm literally putting within my CTE. We take that, remember, this is the result of that query. We take that, put it into our CTE, Littleton, and then I'll press enter and close it in parenthesis. So this is now my inner query over here. And now let us build the outer query. Much like our subquery, let me just go up a little bit. It will be exactly the same as that subquery or main query over here. So it'll simply say select all from. Now this is the part that differs your subquery and your CTE. On our from, we're just going to do orders. Sorry. We're just going to do orders, and then we are going to say where our customer ID is in the select customer ID. Select customer ID from, this time we want it from the customer city, because that's our, there we go. And we enclose that because that is where our CTE is. So the CTE is where the filtering is happening, right? And so when we run this, there we go. We can see that we get the exact same result as the one above here. If I collapse, you can see it's exactly the same. There's 53 rows that are returned and affected. And when you come down to the CTE, you can see it's the exact same thing. 53 rows affected, right? And so we've just built a subquery and CTE from scratch. And you can see that when you move slowly with that logic of let's build up with the first little block and keep on building on, it becomes much easier. All right. So I'm going to simply collapse those once again, and we're going to move up. All right. And next we are going to go into our from clause. So now for the second question, it asks us to find the total revenue for each product. So here we've got a set of instructions that are telling us or guiding us on how to do it. So the first is get the price for each product and look through the results, right? So that's the first part of our subquery. So what we're going to do is we're going to say select product ID, And our order item subtotal, order item subtotal. And we're going to get this information from the table order items. And then, yes, when we run this, let's see what output we have. You can see there's 172, 198 rows that are affected. So that's a lot of rows, right? I should have put, this is why it's important when you've got bigger sets of data to then put, let me just, to put your limit, right? As you can see, my system was affected by just the sheer volume of the data itself, which is why it's always important when you've got very voluminous data to always put limit and then put your limit 5, limit 2, limit 10, however much you want, right? And so let's say limit 5, so that it, there we go. So when we run that again, we will see, all right, there we go. That is much more palatable. So for you guys, I know a lot of people were complaining, especially around this time, like my system is slow or my query is not coming out. I just gave you a tip on how to deal with it. Limit the amount of output that you have if you don't want your system or your query to take enormous amounts of time, all right? And so, as you can see, what this query just gave us was the subtotal and the product ID for each item that was ordered, right? And so we found the price of each product. This is it. Now the second part, because we want the total revenue, we then use this to get our total revenue. So how we do that is we enclose this in parentheses. I'm going to quickly enclose this and remove that part. I'm going to close in parentheses. And then what I'm going to do, let's just say enter. I'm going to then say select product ID, because it's the one we're looking for, product ID. And then because we want the total in the charts, which function am I using to get total? I think everyone knows this one by now. Please open the charts. Which function do I use to get the total? Sum. Yes. Perfect. Sum. There we go. You guys are brilliant. Like at this point, you should be leading the webinar, not me, right? And so thank you very much. I'm now going to close the webinar, sorry, the chats. So at this point, let's continue. So we say sum, and then we want the sum of the order subtitle. So order item subtotal. For those asking why I'm using order item subtotal is because remember, this is the column that has got the prices for each item, which is why we're getting the sum of that particular column. All right, so we select that and then we say from. Now here is the nice part. Because we already have the information here, we then using, remember we said the from clause is now becomes the data set that we are querying from. So now we are querying from this result over here. And then remember we've got a non-aggregated column, which is product ID over here. And so let me just quickly show you what happens if I do not add group by. If I was to run this function, you can see it gives me an error, right? And so now if we actually, let's say as subquery, let me just quickly give that as subquery. And if I still run it, you can see here, it says in an aggregated query without group by expression list, right? And so we need to then come down and put our group by. So this error is just telling you because you've got a non-aggregated column project ID, you need to actually group it here. So we say group by that non-aggregated column, which is product ID. Now, when we run this, you can see the error is now gone. So that's another tip for you guys. That's there. Remember, every time you've got a non-aggregated column like name, product ID, customer ID, whatever it is, and you use an aggregation, always group it at the end there, right? So you don't run into errors. Now we can see through our data over here that, okay, so this was the query we're building. Now we've got the total of each of these items, right? And so product 947 within our order item tables, this was the total amount that customers paid towards this particular item, right? And so now we've got what was the question? The total revenue for each product. So as you can see, guys, it's actually very simple to build upon the subquery as long as you keep on putting it in batches, look at your result, and then reference that result back into the main query, and you keep on building it like that. All right. So next, we then go into question 3, which asks us, find customers who haven't placed any orders at all. All right, so I'm just going to, sorry, let me move that. There we go. So now we're going to find customers who haven't placed any orders. For this part, I think you guys are champs now, so I'll leave you to take this one and turn it into a CTE as your homework. You saw what I did above here, how to turn it into a CTE. You can also do the same for this one. That's your homework for you guys. Right. And so now here, we want to find customers that haven't placed any orders. So remember how last time or last week we talked about, their customers in the customer table, but these customers who haven't placed any orders, they won't be in the orders table because they haven't placed any order, right? So with that logic or that line of thinking, we can then say select, because we want to find the names of the customers who haven't placed any order at all whatsoever. We find the first part of it is we can find distinct, am I spelling this correctly? Distinct, there we go. Customer ID, because we want to find customers who have never placed orders from the orders table. And when we run that, we can see, okay, so these are the customers that have placed orders. So in this case, these are all the customers, 12,405 customers have placed orders within our orders table. So now we're trying to find those that did not place those orders. So essentially, if we think or if we reverse engineer the logic of, okay, so here our result, we've got all the customers that have placed the order. Now we want to find those that haven't. It means we need to find any missing values between the customer table and the orders table. So again, we enclose this in parentheses to tell it, okay, we're doing a subquery. And then I'll say select And then here, because let me just quickly go back to the very top. Because our name, our customer name is in first name and a last name, I'm going to simply do a concat to join the first name and the last name so that when we view the result, it will be simple and straightforward. So I'm going to use concat and I'm going to say customer first name and customer last name, comma, let's leave a space between the two, and then customer last name. And we enclose that. And then we're going to say in the result, name this customer name. Just simply customer name. And then from there, we're going to say from customers. And now the condition that we want is where our customer ID is not in our subquery here. So remember this result that we have at the bottom. So we're looking for customer ID that is not in these 12,405 rows, right? And so when we run that, you'll see now, there we go. We've got all the names of all the people that have actually never placed an order in the orders table, right? And so you can see like, oh, so we've got 30 customers within our database that have never placed an order, right? And so this is how we are simply building up your query step by step, which is why I said it's the logic that will take you through how to actually do all these things, right? Not just simply, oh, we're just building something. Now, I've got a question for you guys. And I know this is more of an advanced question, but I want you to take a shoot at it anyway. So here I used the clause not in, right? Just to find any missing values. So which alternative do you think I could have used here instead of not in? Please open the charts. Instead of using not in, which other function do you think I could have used there? Or wedding? Not equal is not. Okay. Not equal is not, if now. All right. I don't know. Okay, yeah, it's all right to not know. That's why I said it's a bit more of an advanced question. Is not. Okay. So for this part, thank you, accept now. Please tell us. Okay. All right. So I will close the charts now. So for this part, what would have been actually better instead of not in would have been not exists. Why not in is quite, when you run that, where is the problem here? Okay, let's leave not in. Why the not in can be a problem sometimes is that if, for example, there were null values, then the entire query might actually return no results. So if it was like, oh, there's 0 rows affected, it'll just bring back blank. So yeah, which is why it's important to use other clauses over here. All right. Now that we have done that, I'll do that. We will now move over to the MySQL workbench and continue our questions from there. All right. So now Now that we've established like, okay, now we are in the groove of creating our subqueries, we're in the groove of creating our CTEs. Let us now move on into MySQL Workbench and see how we can build the following questions that are over here. All right. So just one reminder, remember when you start to build your subquery, to start with the result that you want first and then adding your main query to it. So now here we need to find high value items that are above the $900 threshold. So how do we do this? We first say, okay, let's find the items that are actually above $900. So we look through our order items table, where our condition is that it needs to be more than $900. So the order item subtotal needs to be more than 900 in our case. And then let's see, when I run that, all right, you can see like, oh, these are all the items that are there. Like, okay, these are all the items that are above $900, right? So this is the result that we will be using when we are using our subquery. So this time, since we've been building subqueries, I'm going to use a CTE to encapsulate this so that it is easier to understand. So I'm going to encapsulate that in parentheses, press enter, and then I'm going to name that as a high value order. And then I'm going to say, name it as, and then we're going to put our select or our subquery over here. Then we're going to enter that back, close parentheses. And then we come down here and now we build our main query. So we've got our CTE with the subquery inside it. This is the result of, okay, these are all the items that are above $900. And so now we can simply say, select everything from, now we are referencing our CTE from high value orders. So high value order. Orders, was it order or orders? Okay, order, yeah. And when we run that, we can see like, oh, okay. So these are all the products. As you can see, something has changed here. Now we can see all the products that are above, 900 from 1999 and 999 and all of them. And as you can see here, it's 25 rows that were returned. All right. And so there we just found all the high value items that are above the $900 threshold. All right. And so we've simply built, a subquery, CTE in this at this point in time that uses, conditions, and we're filtering, the entire condition that we set over here. Now let's continue building on that momentum this time around, and let's now go into the second question, which then asks us to create a CTE that shows products that are priced above their category's average price. So in this case, we need to first find the products that are above average. So I'm going to say select. This is the nice thing about, working in tools like MySQL Workbench. As you can see, it gives me suggestions as I start typing in different things, right? So category ID, and we want to get the average. So we want to first get each category's average price. That's our first aim over here. So we first get the average of the product price. And then I'm going to alias that as the average price. And then say from products table, from our products table. And then we're going to remember rule of thumb, if you put a non-aggregate column in your select clause and you use an aggregate function, always group by. Yeah. If there's anything, please think that after today's webinar, always remember to put your non-aggregate when you aggregate anything in your select clause. So when we do that, and when I run that, I'm using Command Enter to run this one. You can see like, oh, okay. So these are all the categories that we have, and these are the average prices for each category. So with this result in mind, and we can see there were 55 rows, which tells us, okay, there are 55 categories that are there. So with this result in mind, now we can even encapsulate this in our parentheses, since it told us we are creating a CTE. So we enclose that in parentheses, and then we start with with clause, and then we say category ID. Oh, sorry. That's category average. So I'll just say AVG is, and then we've got our subquery over here with this result. So always keep this result in mind, like, because that's where your main query or outer query will be getting the information from. All right. And so we said that CTE, and then we press enter. We now input our outer query. So now we saying select the following information. I'm going to choose product name, because we want to show products. So which means we also need to see the product name. So I want to see the product name and the product price and the average price from category average. So average price, AVG price from our products table. I think everyone can already see where this is going. When you saw me putting P dot and you're seeing me going there, in the charts quickly while I'm finishing typing this up, what do you think? What is the next clause I'm going to put here? I think this already gave it away. It was from last week's lesson. Which clause am I going to put after from here? Having joined with join. There we go. Ding, 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 ding. Everyone has it. Everyone has got it. So we're all on the same game. We're all on the same page, guys. This is amazing. This is amazing. We're working together. I love this. I love this. So we are joining our information. So we come back here and we say join and we say category. Guys, I also need to have some laughs sometimes because a lot of the time it's like I'm talking to myself. So here we go. We do category join, category average, CA. We'll join that on the category ID is equal to our CA category ID. I'm loving all the love, guys. I am loving it so much. And then we'll say where our product is, our product price. There we go. Tab is greater than our average price. And so when we run this query over here, let me just do that. And I run that. We can see like, oh, so these are the products that had remember what our key function was? Above category average price. So remember the previous function, it had only shown us the average price of each product, right? Now it's showing us, oh, so these are the products that are above. As you can see, this product like Adam's Golf Woman's Idea Tech, it's $4.99. The average price is $2.89, you know, and these Adidas, I'm sure, official match ball. Okay, so the soccer ball, I'm guessing, is above the average price in that category of maybe soccer items, right? And so as you can see, when you build on your logic, slowly, bit by bit, you will get to the final result. So always start with the smaller, smaller block. Even if you don't understand where it's going, start with the smaller block and keep on adding to it until you get to the result you want. Hence, when I said, remember at the beginning, before I even made the very first subquery, always imagine what is it that I want to see at the end. It'll help you then say, okay, connect the dots to each other. All right. And now here is one that I want us to go through because you are going to meet this in your integrated project, but it's still going with what we have. So we're going to touch upon case statements, and then we're going to build up on it, in like real life, using a real life scenario that you actually might meet when you go out into the workplace. All right. So for our case statement this time, it's telling us to create a query that categorizes our products into 3 price tiers. And then it flags those price tiers if the price is above or below the store average. And then it orders, let me just do that so we can see the whole sentence. It orders the result from highest to lowest price. So how we can achieve that is we start by our select statement. All right, we start with our select statement and we say product name and the product price. Product price from, oh, sorry. Before we do the from here, okay, what's going on? Before we do the from here, we're going to introduce what's known as case. And then in our case statement, so this is why I said we're building on all the stuff we've been learning from Flowcharts 101. So case statement is like your if or else or that type of logic that goes there, right? It's like if else, in Google Sheets, we went through all the different conditions and everything. And so this is MySQL's version of if this, if not, then else this, and we go on like that, right? And so we can say the case, I'm just going to say enter, and now we start putting in our condition. Our first condition is when the product price is greater than 1,000, for example, because we're trying to look for more expensive items for those that like the bougie items, and we'll call these the premium items, right? We'll call these premium items. So now we are busy categorizing because it told us to categorize the products. We are busy categorizing the products. So, and then when a product price, let's see, product price is greater than 400, then we will say it's mid-range, right? So if it's anything between 1,000 to 400, we'll then call it a mid-range item. We're just busy categorizing. Please bear with me here as I else. If it's not a premium item that's within this price range, or if it's not a mid-rate item that's within this price range, then we'll just call it a budget item. Though I do not know of any budget items that cost $400, guys. Budget item should be like $20, $10, especially in Africa, just saying. Anyway, and then we are going to end that statement as, and we're going to alias it as price tier, right? But yeah, I'm making that joke because this is an American, this was an American database. So this is not me. This is, yeah, this is that. So as you can see here, what we just did was we just did an if-else statement, right? Of this was case when the product is 1,000, then we label it as premium. When it's between 1,000 or 999 and 400, then it falls into mid-range. Otherwise, just call it a budget. And then you always need to, when you start your case statement, sorry, you always need to end with end, and then name it your alias of what you want the column to look like, price tier. And now that we've named the price tier, I'm going to just do one more case statement over here and say case, once again, I'll drop there when the product price, dot product price is greater than, and now this is where it's going to just get slightly more complex. Now we're just going to put another subquery because remember our query here was asking for the price above or below the store average, right? So now we're trying to establish this, whether it's above or below the store average. So in this, we've categorized. Now we're getting the average, and then finally we're going to classify and put it whether it's above or below. And so for the next part, we're just going to, this is to find the average. So I'm just going to quickly say average of our product price. Let's see, product price, close that from our products table, and close that. Bear with me, guys. We're almost there. We're almost there. We're almost there. Then, above average, right? So now we're classifying again. We're saying everything is above average. If not, then else. Call it below average. So we're classifying once more below, below average. Why I'm doing this example is because you're going to meet this in your, what do you call it, in your integrated project, and you're going to be like, but they never taught us this. Yeah, here I am teaching it to you. Comparison. Yeah. And then we're going to get all this information from our products table. All right. And we're going to name that as P. And when we run, hopefully I don't run into errors. There we go. All right. So let us quickly just walk through what I just did once again. So what I did was we wanted to get the name and the price tag of each product. So the very first thing we did was we put it in an if-else statement to categorize whether it's a premium product, mid-range product, or budget product, right? After establishing that, we then named it as price tier. And then we used another if-else again to just find our average product price for all the products. Once we established the average product price, we simply then told it to give us, oh, this is above average for each product. or this is below the average for each product. And that is simply what we did. And as you can see here, in our, is there a way to enlarge this result so that everyone can see properly? I don't know. But anyway, as you can see, if you go and you read, we scroll down this, you can actually see there's budget, a lot of budget items, but there's mid-range as well. And then there's premium items as well that are hidden in there somewhere. Let's see if we, okay. Okay, it's not changing, but it's fine. But anyway, as you can see, the result is now we've got the product name, we've got the price of each product, and then it tells us whether it's a budget item or not. And then it tells us, oh, so according to this product, it's either below average or it's above the average price. So that's what we just did. So we just did an if else ladder or statement, right? And so now that we've got this entire thing, what I'm going to do is, because of time, I'm going to encapsulate this and we're going to try and answer a real world question that you might actually end up meeting, right? And I'm going to copy this entire query that we just built. And here's our real life scenario, right? I don't know if, let me just enter. Okay, there we go. So our real life scenario of this tier question. So imagine you're working for a store, and remember Moanwa's story last week? Now she's asking, or a manager asks you, right? They want us to count how many of these products fall into each tier, right? So we need to modify our query to show this summary. So now it's just simply a matter of building on the logic that we have and saying, let's say select, we're going to say price tier because that's the name that we built for the price tier that we have. And then we're going to count. Why are we counting? Because they want us to show how many, the key here, the keyword here being how many products actually fall into each tier, right? And so we're trying to find out like, okay, how many of these products fall into the different categories that we just classified. And then I'm going to, okay, I'll leave this blank for now. And then I'll group everything by the price tier before we paste and before you lose sight of where we are. And then I'm going to enclose that. And then here from, because remember it built this result, it's now like its own data set. So we put that query that we built there here. And we alias it as, let's say, categorized products. And now when we run this query over here, let's see. We can see like, oh, so for our premium items, we've got 5 products that fall under it. For our mid-range products, we've got 42 items. And for our budget items, we've got 1,298 products, right? And so this is just, we've categorized things. Now we're counting things. So that logic of, if you see, I've been highlighting, if you're following carefully, I've been highlighting certain keywords that you can use to then determine which function, which clause to use. All right. I think because of time, I am going to stop here. There are some extra practice questions that you can go through. In my SQL Workbench, you will get this these notes. I will also paste within the links on the slides for you to have these solutions as well that we built within the webinar. And now the final thing I also had for you guys, because I know this is a particularly more involving topic, I also put a few tips for you for the integrated project that you can just go through to take you through, and also some just debugging and common pitfalls within your notebook. All right, so with that said, let us get back into slideshow. I will then go on to the notes. So remember how I touched on subquery CTEs and views in the slides, but I didn't touch on views at all within the demo. So there's a recording, first aid session recording that already has this information with the slide deck and the demo, so that you can also follow along how you create views as well. Another reminder for you guys, please remember, on your very first attempt, you can score up to 100%. However, once you've used that first attempt, the other 3 supplementary tests, they're all capped at 50%, which means even if you get 100%, it'll only show as 50%. So use your retries wisely and use your first chance wisely as well. All right. And with that, I will now take questions. All right. So let me open the Q&A. All right, so Precious is asking, why do we have 8 rows for the customers who live in Littleton? And then we have 53 rows for orders from the same customers in Littleton. Okay, Precious, I actually glad you asked this question. Back, let me just escape my screen, go back to this particular one. So this comes back to, remember how we established relationships in ERDs last week? And we were saying, min, max. So there can be 8 customers, but those 8 customers can have, let's say, 20 orders in the order table. So one customer can place, so for example, let's say Amazon, right? If you love using Amazon, you're going to order, maybe today you order, by the way, today is my brother's birthday. So let's say, for example, I order him like a smartwatch because that was on his wish list. And then tomorrow I order maybe a pair of Crocs because I love Crocs. And then next week, maybe I order a phone because my phone is about to die on me. It's very slow now. That's 3 orders I have made. Yet I am one customer. So that is how it is possible to have 8 rows. Thank you so much, guys, for the love. How we have 8 rows or 8 customers that live in Littleton, but then they've got 53 orders altogether. All right. And then how many hours? Okay, I don't think I'll be able to answer that one. I don't think it's a timed exam, actually. But maybe I can ask one of the technical mentors or program manager to help me answer this question. Is the exam timed?
Yes, Shagan.
All right. Thank you very much, Vanessa. So the exam is not timed, and the exam will be open from next week, Monday, 23rd, and it will close on upper week Monday, that's the 30th of June. The exam is not timed, so you can do the exam within that period, but just remember you have to submit before the deadline to stand the chance of getting like your full 100%.
All right, thank you, Shagan. And sorry, would you also like to take the next question of, will it be based on the Majindogo database? I know it's not, but yeah.
All right. It will not be based on the Majindogo database. It will be based on a different database. And the exam will be on Jupyter Notebook. So that is why we have been using MySQL Workbench and Jupyter Notebook concurrently throughout the webinar delivery so far. Yeah, over to you, Manesu.
All right, thank you so much, Shagan. And then the last part of question 3.1, order from highest to lowest, was not answered. Okay, let's see. Was it, I can't remember if it was in the notebook or if it was in the simple workbench. Sorry, these fluids. Okay, if it wasn't answered, you know what you can do. That's your homework. You can find out how to order it. But the clue is you can use order by. And either do descending if you want it from highest to lowest, or ascending, or just leave it as order by the specific column. All right, so that'll be your homework. I've already given you a hint on how to answer that one. All right, and then what if I exhaust all chances? What other chance does he or she have? If you exhaust all your chances, I'm assuming you're meaning the supplementary tests. Unfortunately, it means you would have failed the particular assessment, which is why we said, please, please, use your chances wisely. Like if you see maybe first and second chance, you're not getting it, try to go back to the content to see, go through the walkthroughs. I mean, in SQL, there's so many walkthroughs on how to do things. If you're still not understanding, go on to AnswerBase, ask your question to see if you can be helped. There's also a repository of questions that the other past cohorts, multiple cohorts have asked. So probably your questions might also be in there. All right. And then let's see, is our tutor open to mentorship and how can she be reached? I think this one, unfortunately, we do stick to the guidelines of the ALX, where we'll only be reachable on AnswerBase, or if you want to talk on LinkedIn, but I'm currently not open to mentorship at the moment, but happy to connect. All right. And then for the first CTE exercise, why did we do this for the where clause? So where customer ID in select ID from customer CT and not where customer ID, customer CTE already contains the ID. Okay, Sarah, that was just my logic of putting it in there. But you can try it out. Remember, at the end of the day, these, what do you call it? These queries that I built, they're based on my logic and how I was laying it out. So the way you might think, you might actually be better. You might have a different logic and a better way of approaching this. So, as they say, there are many ways to skin a cat. So this is one of those ways. Use your logic as well. If it's simpler, faster, you can do that. But yeah, this was the logic I used when I was building it. But yeah, both, as long as you get the end result is what we need. All right. And then, not sure. Right. If you're having issues with Jupyter Notebook, okay, for this one, okay, I'll go to Dennis on last question. Was there a need of aliasing the product table is P, and yet we were not joining it with another table? So I'm assuming you mean this particular one over here. So why I was simply what do you call it? Why I was aliasing it as P. You can do it without the alias, but I was doing it so that I do not forget any part, especially when I'm building my if else between the categorizing and getting the averages. That's why I used the alias, but you can try it without the P when you get it and see if it works for you. All right, and then is it Is it a must to take the exams test on Jupyter Notebook and MySQL, Blanche alone, or other tools can be used? So for this one, you will have to take it on, I think it's a Jupyter Notebook. Sorry, I'll ask another technical vendor to help me answer this question again.
Yes, Shagan.
All right. I've been seeing lots of questions that has to do with the exams and the Jupyter Notebook and MySQL. So when the exams will be open, you'll be provided with a database, a .db file, and the Jupyter Notebook. So the Jupyter Notebook is structured in such a way that you just need to go to the cell to type in your query, and the questions are laid out on the notebook. So it is easier to do the exam on Jupyter Notebook. However, if for any reason you are having issues connecting your Jupyter Notebook to MySQL and you have been having the connectivity issues, yes, you can connect your database directly to MySQL, but you will still need the Jupyter Notebook to guide you in following the questions on the notebook. So yes, you can use MySQL to connect your database and interact with the data and answer the questions, but it will be way easier if you use Jupyter Notebook directly. I hope the question is answered. Yep, over to you, Munesu.
All right, thank you so much, Shagan, for that response. And I think I'll just take one more question. So I'll join these two anonymous questions and answer once. So the certification you'll be getting after the course is your data analytics, your machine learning, data science certificate. I think in terms of if you're getting specific associate certificates, you'll just be getting, if you do complete the AWS exam, that's the one you'll be getting, but you'll be getting more like a general certificate. And then as for those who are still behind, please do try to catch up, yeah, as much as you can. There is a lot of materials that are provided for you to, to be able to do that. And there will be a grace period that is given, but do not bank on that. Please do try to catch up as much as you possibly can. And I think with that, I will hand it back over to Mr. Peter.
Hey, hello. Thank you so much, Munesu. What an insightful sessions. Guys, let's show Munesu some love. She's done an amazing, amazing job. Thank you so much, Munesu, for such an insightful session. I hope that if you have been on the call and followed everything through, this should be helpful, even not only just as you tackle this week's content, but as you think through your way as a data analyst. So thank you so much once again, Munesu. So, but before we go to even the announcements, I would also like to say thank you to the amazing team that has been working behind the scenes, answering questions in the Q&A section, the data scientists, technical mentors who have been, on the call throughout, ensuring that all your questions are answered. Thank you so much, guys. And lastly, if you still have any questions, guys, remember we have AnswerBase. You can always post your questions. Our TMs are there and they're ready to support you. But beyond that, mainly remember to lean on your peers in your squads. Ensure that you're really leveraging on the community to assist in every step along the way. So on to our announcements for today. What are we expecting? Remember, the MCQ for this week is due on Monday 23rd. So what are you waiting for? Just make sure that you pace yourself so that you complete it before then. Then the other very important thing we would like to share is that remember a while ago we started having SGD leads, study group discussions, which are being led by your fellow peers who are the leads in your squads. So please spare time to join these sessions. It's always better walking the journey with people who you can relate to, the people who are walking the same journey as you are walking. This is really helpful. So spare time to join these study group discussions, which are being led by your peers, and support each other. That's the whole point of the study group discussion. There might be challenges that we as the program team cannot see on the ground, but when you come together with your peers, you can actually assist each other. So please spare time to attend these sessions. The session details are always posted in your squads by the squad leads, so be on the lookout for this. And we have had so many questions around the exams. Wow, guys, are you panicking? But as we said when we were beginning this session, you have come so far. You have come so far. You have done so much. So what is it? Like, we really believe in you guys, and we believe that you're going to do this. So get ready for the exam that is coming next week. In Kenya, we have this phrase that we say, get ready, get ready, get ready. So yeah, get ready and ensure that you are up to date with everything as you prepare for the exam. But anyway, thank you so much for attending these sessions. You guys have been amazing. In case of anything, as we've said, if in case you have any other questions, please use AnswerBase and the community spaces. And beyond that, if you have any technical issues, please remember to raise a ticket on Zendesk. So thank you so much for joining. But before I go, the last thing, I swear this is the last thing, don't stone me. I would like to take a moment and, to my Kenyan people, everyone in Kenya, the situation is tense. So guys, stay safe out there and ensure that stick together through these very difficult times, but we are with you. We are together in this journey. So all my Kenyan people, be safe. That's all I'm going to say. Stay safe. But thank you so much for joining this session. Thank you so much, Munesu, for being an amazing host as well. And see you next week. See you in the community spaces. Have a lovely Wednesday and rest of the week. Bye-bye, guys.
Leo sapa tunakuladi mpishi, bora tushibe. Mwiko refu tunafungadi mshipi, bora tupike. Kamba ya buto mneza gongewa, hauna mbota na bado timing unatolewa. Bora mpishi jumpishi, bora shaolewa. Busy but niko easy ganji kitolewa. Baby don't touch me there, me gonna wake you in the air. I'm easy touch me there, sugar down low find me there. Nikisha kanyaga sin, I'm always on time. Gonna pay your number, gonna pay a gaki calls. Likunisha ndenka jipata nimedoze. Zidona deli hini dawa hini dose. Spirit iko so high, wezi shusha walai. Baby don't be so shy, tisha Kenya na die. Feeling really high, Kila kitu alright, Baby don't touch me there, me gonna wake you in the air. I'm easy touch me there, sugar down low find me there. Reverse, nikisha kanyaga sin, I'm always on time. Lagunya see my feet, kwenye ninyo ni magrill. Feeling really high, I'm feeling best, take it really nice. I'm really blessed, take it you cannot deny. Feeling really high. Anadai kumedi bas mi do medicine. Na doba zangu kwa keni therapy. Mzimbe ting, na kutibu from within. Win is a win, nikisha kanyaga sin. Mohana nice and lovely, sweet and sexy girl. Won't you catch a wine for me? And take me back to December. Ukipuliza kipenga, imechi wendo referee. Ashifura